Long before telescopes or written language, humanity mapped the stars with nothing but stone and fire. This is the story of ancient astronomers who achieved a cosmic precision that still baffles scientists today. By the end of this journey, you will see the night sky through the eyes of our ancestors and understand secrets lost for millennia. How could massive stones predict solar eclipses with perfect timing? And what forgotten knowledge was preserved only in flickering firelight? What does it truly mean to chart the heavens with only your eyes and the world around you? Our ancestors first raised their eyes to the heavens not as scientists, but as storytellers searching for meaning in the dark. This was the birth of astronomy, a primal connection forged in the silent dialogue between earth and sky. They noticed how certain star patterns returned with the seasons, how the moon swelled and shrank in a reliable rhythm, and how a few bright lights wandered mysteriously against the fixed tapestry of the night. These were not just random points of light, they were the first chapters in a cosmic story. That story was essential for survival. Knowing when the rains would come by the position of the stars meant the difference between a harvest and a famine. Tracking the moon's phases created the first calendars, giving structure to time itself. This knowledge became sacred, woven into myth and ritual, because to understand the sky was to understand the very order of the world. This fundamental human impulse to observe, record, and find patterns in the cosmos is the true foundation of celestial mapping. It all began with this deep, innate curiosity. But curiosity alone could not chart the heavens. It needed a physical form, a tool to translate observation into lasting knowledge. A single standing stone, silent and unmoving, became humanity's first permanent astronomical instrument. These solitary sentinels, whether found naturally or placed deliberately, transformed the vast, shifting sky into something measurable. An observer would simply watch the stone's shadow throughout the day and across the seasons. They saw how that dark finger stretched long and thin in the winter, only to shrink to a stub at the summer solstice. The precise point on the horizon where the sun rose and set would also shift, and a strategically placed stone could mark these extreme turning points of the year. This was the birth of the solar calendar, carved not on paper but into the very landscape. It required no advanced tools, only relentless patience and a deep generational memory. The true genius lies in this simplicity. By using the unchanging earth to track the moving heavens, they created a system of timekeeping that was both profoundly sophisticated and elegantly basic. This foundational act of marking the sun's journey with stone and shadow set the stage for something far grander, a leap in ambition that would lead to structures that still dominate our imagination today. While stone marked the steady path of the sun, fire unlocked the secrets of the night. In the deep darkness, a bonfire became more than just a source of warmth and protection. It transformed into a living observatory. Its light pushed back the shadows, allowing ancient watchers to trace the slow dance of planets and the fixed patterns of constellations for hours on end. But its role was far more sophisticated than simple illumination. A fire deliberately built on a high hill or in a sacred clearing became a fixed reference point, a terrestrial star against which the movements of the celestial ones could be measured. An astronomer would line up a bright star with the top of a distant mountain peak, using the fire's glow as a guide to ensure their sightline remained true night after night. This simple act turned the entire landscape into a giant measuring device. Even the smoke and heat played a crucial part. The behavior of the rising smoke column revealed the subtle air currents high above, warning of atmospheric turbulence that could make the stars shimmer and distort their true positions. Meanwhile, the heat from the flames created a thermal layer that actually steadied the air closest to the ground, providing a clearer, more stable window to the heavens. This was not just science, it was a profound ritual that connected the community to the cosmos. When a meteor shower streaked across the sky or the moon slowly turned a deep copper red, people would gather around these great fires. The event was witnessed collectively, and the stories of what it meant, the myths of dragons in the sky or gods in conflict, were passed down through generations, cementing astronomical knowledge in oral tradition. In those moments, the flickering of the flames below seemed to answer the twinkling of the stars above, a silent conversation between two kinds of fire. This elemental partnership between stone and fire was the bedrock of cosmic understanding, a foundation upon which everything else would be built. From solitary stones and ritual fires, humanity's cosmic ambition grew to an immense scale. We began to engineer the landscape itself, raising colossal stones into patterns that echoed the heavens. These megalithic structures are the ultimate expression of early astronomy, a silent language of granite and sunlight. They were not just monuments, they were precise machines built of stone, designed to capture the sun, moon, and stars at their most powerful moments. To position a 20-ton slab so that the sunrise on the longest day of the year slices perfectly through a narrow gap requires a breathtaking understanding of geometry and celestial mechanics. This knowledge was not written down in books, it was held in the collective memory of a culture, passed orally from one generation of builders to the next. The effort involved was staggering. At places like Stonehenge, multi-ton bluestones were transported over 150 miles, a logistical feat that speaks to a unified, society-wide purpose. Why go to such extreme lengths? Because these alignments were the beating heart of civilization. They marked the solstices, telling people exactly when to plant and when to harvest. They predicted eclipses, events that held immense spiritual and political power. They created a permanent, unshakable calendar in a world governed by cycles. Each massive lintel and towering trilithon was a line of code in a stone computer, a physical manifestation of generations of accumulated sky wisdom. The silent, enduring presence of these sites proves just how vital celestial observation was to our ancestors. It was a matter of survival, faith, and order, all locked into the alignment of rock and light. This drive for precision did not stop with marking the annual journey of the sun. It would soon turn to the more complex and subtle movements of the moon. The sun's path across the sky is not a constant highway, but a living river that shifts with the seasons. Ancient astronomers mapped this river's banks with nothing more than stone and shadow. They established a fixed observation point, perhaps a single post or a carved notch in a rock, and from that vantage, they meticulously recorded the sunrise and sunset positions along the horizon. Day by day, they watched the sun's rising point creep steadily northward until it reached a limit, the summer solstice, before beginning its slow retreat south. Half a year later, it would reach its southern extreme, the winter solstice. The 2 days in between, when day and night were of equal length, were the equinoxes. Identifying these 4 celestial turning points with precision was the key to unlocking the solar year. This was not an abstract exercise, it was the very engine of civilization. Knowing the exact date of the solstices told a community when to plant their crops to catch the spring rains, and when to harvest before the autumn frosts. It dictated the timing of sacred ceremonies, ensuring rituals were performed when the cosmic power was at its peak. This solar calendar, born from patient observation, became the immutable rhythm of society. From this foundational rhythm emerged the concept of a 365-day year. But the true genius of these early timekeepers was recognizing that the solar year is not exactly 365 days. It is closer to 365 and a quarter. Over centuries, that extra quarter day would slowly shift the seasons, causing a calendar to drift out of sync with the sun. To correct this, cultures from the Egyptians to the Maya developed sophisticated intercalary systems, adding extra days or even a whole month at precise intervals to keep their calendars perfectly aligned with the heavens. This achievement, emerging independently across the globe, stands as one of humanity's greatest intellectual triumphs, a testament to what can be accomplished with patient eyes and a deep connection to the cosmos. The moon's wandering path offered a completely different kind of challenge. Unlike the sun's steady annual rhythm, the moon is a shapeshifter, transforming from a thin silver crescent to a brilliant full disk and back again in just 29.5 days. To track this elusive cycle, ancient astronomers invented tools of remarkable ingenuity. They carved notches into animal bones, one groove for each night, creating a physical tally of the passing phases. They arranged stones in rings, using each stone as a marker for a day in the lunar month, a permanent calendar etched into the earth. Under the cloak of darkness, they used their fire-illuminated observation points to precisely log the moon's position among the stars, night after night. This was not merely about counting days. They saw a profound connection between the lunar cycle and the world around them, linking its rhythm to the powerful pull of the ocean tides and the natural cycles of life. This deep recognition made the moon a central force in their understanding of time, but a major problem emerged, one that would require generations of observation to solve. 12 of these lunar months only add up to 354 days, leaving a gap of 11 days against the solar year. If left uncorrected, the lunar months would quickly drift through the seasons, with a winter moon eventually appearing in the middle of summer. Reconciling these two cycles became a monumental intellectual pursuit, leading to the creation of complex lunisolar calendars that periodically inserted an extra intercalary month to bring the moon and sun back into harmony. Lunar eclipses provided the ultimate key to refining this system. When the Earth's shadow slowly crept across the face of the full moon, it revealed a critical piece of information: the precise geometry of the moon's orbit. By recording these rare events, early astronomers could predict future eclipses, proving they had unlocked a fundamental cosmic pattern. Every eclipse witnessed and recorded was another data point, another step toward a unified map of the heavens where both the sun and the moon had their rightful, predictable place. But the stars themselves offered the most durable canvas for this celestial knowledge. Against that vast, dark tapestry, the human mind instinctively sought order, connecting the brightest points of light into familiar shapes. A bear, a hunter, a great serpent, these were the first constellations, born not from random imagination but from a deep need to organize and remember. Around the communal fire, whose gentle glow preserved the observer's night vision, elders would point out these patterns, using the stones of their sacred sites as permanent sightlines to specific stars on the horizon. This was the creation of the first mental star charts, a system of celestial landmarks that turned the overwhelming chaos of the night into a manageable map. Each constellation also served as a seasonal clock. The appearance of the hunter Orion in the winter sky signaled the coming of the cold, while the summer Scorpion warned of the hottest days. This knowledge was not stored in books but in stories. The myth of the Great Bear being chased around the pole star for all eternity was not just a tale. It was a way to remember that those specific stars never set, that they are always circling the north. These narratives, passed down through countless generations, encoded precise astronomical data within their plots and characters. This mental framework of constellations then allowed for the next great leap, tracking the wanderers. Against this fixed backdrop of familiar shapes, a few stars refused to stay in place. These planets would slowly drift from one constellation to the next, and by knowing the star patterns intimately, ancient astronomers could log their precise paths. They could predict when the bright red wanderer would enter the territory of the Scorpion, or how long the swift messenger planet would take to cross the Virgin. This mental mapping of the cosmos, written in stories and anchored by stone, created a shared language of the sky that could be taught, refined, and built upon for millennia to come. The 5 wandering stars refused to follow the rules. While the constellations wheeled in their predictable, stately dance, these bright points of light would slow down, stop, and even trace looping reverses against the fixed starry backdrop. This retrograde motion presented the ultimate puzzle for ancient sky watchers. To decode it, they turned again to their most reliable tools. They would place a series of stone markers along a sight line, carefully noting the planet's position each night relative to a distant tree or a mountaintop peak. Night after night, year after year, they logged these subtle shifts, building a celestial database in stone and memory. The patterns that emerged were not random. They discovered that a planet like Mars would perform its backward loop at roughly the same interval, a cycle spanning years. This was a rhythm far more complex than the Sun's annual journey or the Moon's monthly cycle. The very difficulty of this task meant the knowledge had to be sacred. Grand fire ceremonies were timed to coincide with these special celestial moments, like when a planet entered a powerful constellation or reached its brightest point in the sky. The ritual was not separate from the science, it was the mechanism for preserving it. In the flickering firelight, an astronomer priest would announce that the Red Wanderer was beginning its backward path once more, just as the elders had foretold. This act confirmed the cosmic order and reinforced the power of their hard-won knowledge. These wanderers were not mere lights, they were living gods. The swift messenger was Mercury, the brilliant jewel was Venus, the red warrior was Mars. Their movements were interpreted as divine messages, omens of war, peace, or plentiful harvest. To predict their complex dance was to understand the whims of the gods themselves, achieving a level of astronomical sophistication that connected the human world directly to the celestial one. This deep, generational project of mapping the planets paved the way for an even more ambitious goal, one that required a permanent and monumental record of the entire sky. The ultimate test of this celestial knowledge was predicting an eclipse, to announce the precise moment when the sun would vanish or the moon would turn to blood, was to speak the language of the gods themselves. This was not magic, it was mathematics born from generations of relentless observation. Ancient astronomers used their stone alignments and fire-lit observation posts to keep meticulous records. They carved notches on bones and marked stones to log every time the Earth's shadow fell on the moon or the moon's silhouette crossed the sun. After decades, then centuries of this patient data collection, a pattern emerged from the chaos, a grand celestial rhythm known as the Saros cycle. They discovered that a nearly identical eclipse occurs every 18 years and 11 days. Imagine the dedication required to see this pattern, a cycle longer than a single human lifetime. One generation would record a total solar eclipse, and their grandchildren would witness the next one in the sequence, confirming the prediction made generations before. This long-term coordination of lunar and solar cycles required a sacred duty to record keeping, a chain of knowledge unbroken for centuries. The ability to forecast these events conferred unimaginable power. when an astronomer priest could stand before their people and declare that the sun would disappear on a specific day, and then it did, their authority was cemented. It proved that the cosmos operated on knowable principles, and that humanity, with patience and stone and fire, could decipher its deepest secrets. This was the pinnacle of ancient sky watching, a sophisticated understanding of orbital mechanics achieved millennia before the telescope. But this knowledge was not meant to be kept in the dark. It was destined to be etched into the very skin of the Earth on a scale that defies belief. The entire horizon was their clock. Ancient astronomers transformed their familiar landscape into a vast cosmic instrument, reading the seasons from the sun's shifting stage. They would choose a single, unmovable observation point, often marked by a specific stone or a carved post. From this fixed vantage, they memorized the distant skyline, noting how the sun's rising and setting points slid along the crest of a mountain range or dipped into a distinct notch between two hills. Over the course of a year, the sun would travel north and south along this horizon highway, and its extreme turning points at the solstices were permanently recorded by these natural features. A jagged peak might forever mark the winter solstice sunrise, while a solitary tree on a far ridge could signal the summer solstice sunset. This system required a profound, intimate knowledge of the local terrain, a relationship with the land built over generations. But how did they ensure their sightings remained accurate, especially under the dim light of dawn or dusk? Fire provided the answer. On the mornings of the most important celestial events, a carefully positioned bonfire would be lit. Its flames would not only illuminate the observer's position, but could also cast a dramatic glow onto the specific horizon marker, highlighting the exact notch or peak where the sun was destined to appear. This created a breathtaking spectacle, a fusion of earth, fire, and sky that transformed abstract astronomy into a powerful, visceral experience for the entire community. The Horizon Calendar was a perfect partnership with the environment. Instead of building massive structures to impose order on the cosmos, these early scientists used the world as it was given to them, finding cosmic precision in the shape of a hill they saw every day. This was not a conquest of nature, but a deep collaboration with it, turning the whole world into a sacred observatory. The night itself became a vast turning clock face. While the sun's journey marked the slow passage of seasons, the steady rotation of the starry sky offered a way to measure the hours of darkness. Ancient astronomers realized that the entire celestial sphere pivots around a fixed point, the North Star, and they learned to read this motion with incredible precision. By memorizing the positions of key constellations and watching how they drifted past a stationary stone marker or a specific notch in the horizon, they could tell the time as clearly as we read numbers on a dial. A certain star rising directly over a standing stone might mean it was the middle of the night, while the Great Bear constellation dipping its tail toward a mountain peak could signal the approach of dawn. This was a living clock, one that never needed winding and could not break. Fire was the essential partner in this nocturnal timekeeping. A single, small flame, carefully shielded and placed low to the ground, provided just enough light to see the stone sighting markers without washing out the delicate starlight overhead. This allowed the observer's eyes to remain fully adjusted to the dark, making the faintest stars visible and the alignments razor-sharp. The warmth of the fire also steadied the air immediately around the observer, reducing the twinkling of the stars and making their positions appear more fixed and reliable. On a perfectly clear night, an experienced sky watcher could discern the time to within a small fraction of an hour, simply by watching the unending wheel of the constellations. Mastering this star clock demanded a deep, intimate knowledge of the sky that changed with the seasons. The star patterns visible at midnight in the depth of winter were completely different from those overhead on a summer evening. An astronomer had to carry a mental map of the entire year's celestial cycles, knowing not only where each constellation was, but when it would be in the right position to serve as a timekeeper. This knowledge was a sacred trust passed down through generations. It allowed for the precise timing of crucial nighttime activities, from the changing of guards in a city to the optimal moment for fishermen to set out to sea. Most importantly, it scheduled profound religious ceremonies to occur at the most potent astrological hour, linking human ritual directly to the cosmic machinery. This elegant system, built from nothing but memory, stone, and a single flame, stands as a testament to a forgotten age of timekeeping where the entire universe was your clock. Far from the stone circles of the north, a different kind of solar event demanded a new kind of genius. In the tropical lands, the sun does not just travel low along the horizon, it climbs to the very center of the sky, reaching a point directly overhead. This is the Zenith Passage, the moment when the sun is at its absolute peak and vertical objects cast no shadow at all. To capture this fleeting, shadowless instant, ancient astronomers engineered tools of elegant simplicity. A perfectly vertical stone pillar, its top polished smooth, became the instrument. At local noon, as the sun approached its highest point, the stone's shadow would shrink to a tiny, dark pool at its base. For one precise moment, that shadow would vanish completely, marking the zenith. In other places, they constructed dark, enclosed chambers with long, narrow tubes pointing straight up. When the sun's light poured directly down that tube without touching the sides, it signaled the same profound event. This was not a gradual shift like a solstice sunrise. It was a single, definable moment in time. The entire community would gather, their eyes fixed on the stone or the beam of light, waiting for that magical disappearance of the shadow. When it happened, it was a cause for celebration. Great fire ceremonies were ignited, their flames and smoke rising as an earthly echo of the sun's supreme power. These zenith days, occurring twice each year, were pivotal. They divided the year with razor-sharp accuracy, signaling the start of the rains or the beginning of the planting season. This knowledge was power, providing a perfectly synchronized agricultural calendar. But the Zenith Passage held an even deeper secret. The specific date of this event depends entirely on your latitude, your position north or south on the planet. By meticulously recording the days between their own zenith passages, these ancient sky watchers could effectively determine their precise location on Earth. They were mapping their place in the world using nothing but the sun's highest point and a silent, shadowless stone. A tiny cluster of 7 sisters in the sky held the secret to humanity's survival. Across continents and cultures, from the islands of the Pacific to the plains of North America, ancient astronomers watched for the heliacal rising of the Pleiades. This was the moment, after weeks of being lost in the sun's glare, when the star cluster first reappeared in the pre-dawn twilight. Its faint, glittering return was not just a beautiful spectacle, it was an urgent agricultural bulletin. In Greece, it signaled the start of the sailing season, while for the Maori of New Zealand, it marked the beginning of the new year and the time to plant sweet potatoes. The precise timing of this event was so critical that it was etched into the landscape with permanent stone sightlines. A specific gap between 2 massive stones might be perfectly aligned so that on the one crucial morning, the Pleiades would shine directly through the narrow opening, a silent celestial alarm clock. On that appointed dawn, the entire community would gather in the chill air, their breath misting in the darkness. A great ceremonial fire would be lit, its flames pushing back the night as they waited for the stars to appear. When the tiny cluster finally glimmered into view, a collective understanding passed through the people, the signal to begin the harvest or to sow the seeds. This ritual, repeated year after year, century after century, fused practical necessity with cosmic wonder. The fact that cultures with no possible contact all independently linked their fate to this same star cluster reveals a profound truth. This was not a shared myth, but a shared reality of survival. They were all reading the same cosmic calendar, discovering that the heavens provided the most reliable instructions for when to work the Earth. The Pleiades became a universal teacher, its annual appearance a lesson in how deeply human life was woven into the fabric of the stars. The rhythm of Venus became a matter of state. In the bustling cities of ancient Babylonia, astronomers turned from stone and fire to a new medium for their craft, the wet clay tablet. With a stylus, they pressed the movements of the heavens into the earth, creating a permanent library of the cosmos. Their most famous achievement was the Venus tablets, a meticulous log of the planet's comings and goings over 21 years. They recorded its dramatic disappearance behind the sun and its subsequent rebirth as the brilliant morning star, then its later transition to the luminous evening star. This was not casual stargazing, it was a rigorous state-sponsored project of data collection. The Babylonians discerned a grand pattern, an 8-year cycle during which Venus completed 5 of its synodic periods, its intricate dance with the sun. This allowed them to predict its future positions with stunning accuracy, an intellectual leap from simply observing the present to forecasting the future. Yet this sophisticated work was deeply rooted in the older traditions. The fundamental skill of tracking a planet's path against the fixed stars was honed over millennia by watchers using stone sightlines and fire-lit platforms. The Babylonians did not invent planetary observation, they simply gave it a permanent voice. By translating the celestial dance into cuneiform script, they made a profound transition. They moved from pure observation to systematic recording, from memory to mathematics. A Venus cycle was no longer just a story told by the elders around a fire. It was a number, a formula, a predictable piece of cosmic machinery. This shift laid the entire foundation for the astronomy that would follow, turning the sky from a realm of omens into a domain of law. A vertical stone became the world's most reliable clock. Ancient astronomers transformed a simple standing stone into a sophisticated solar quadrant, a device that measured the sun's altitude with nothing but shadow and marked Earth. The principle was elegant in its simplicity. They would erect a perfectly vertical pillar known as a gnomon and carefully prepare a flat, level surface around it. As the sun journeyed across the sky, the stone's shadow swept across this prepared ground like the hand of a giant timepiece. The key was not just watching the shadow move, but meticulously measuring it. At dawn, the shadow would stretch long and thin toward the west. As the sun climbed higher, the shadow would shrink, reaching its absolute shortest length at local noon, when the sun was at its highest point in the sky. After noon, the shadow would slowly lengthen again, this time pointing eastward. By marking the tip of the shadow at different times of day, they created a permanent sundial, a solar clock that divided daylight into precise segments. This was timekeeping born directly from the cosmos, its rhythm dictated by the Earth's own rotation. But the true genius of the solar quadrant was revealed over the course of a year. The sun's path changes with the seasons, climbing high in the summer sky and staying low in the winter. This meant the noon shadow was never the same length 2 days in a row. In the height of summer, the shadow at noon was a small, compact pool at the base of the stone. In the depths of winter, that same noon shadow stretched long and lean. By marking the tip of the noon shadow every single day, ancient astronomers mapped a full year onto the ground. The line traced by that moving tip over the seasons formed a perfect, graceful curve, a hyperbola etched into the Earth. The extreme ends of this curve marked the solstices, while the points where the curve was straightest indicated the equinoxes. This ground-based map was a permanent, visible record of the solar year. To make these measurements reproducible, they developed a standardized system of measurement based on the most universal tools available, the human body itself. A foot was the length of a man's foot, a handbreadth was the width of a palm, a cubit was the distance from the elbow to the tip of the middle finger. By using these bodily units, any observer at any location could set up their own solar quadrant and achieve consistent results. This was a crucial step from qualitative observation to quantitative science. It meant that knowledge could be shared and verified, that a measurement taken by one person in one village could be understood and replicated by another person 100 miles away. This practical application of shadow geometry was a monumental leap. It transformed the abstract concept of the sun's movement into a set of numbers and angles, laying the foundational principles for trigonometry. The solar quadrant proves that the most sophisticated cosmic understanding can emerge from the most humble beginnings, from a single stone and the silent, patient dance of its shadow. The moon holds one last secret in its complex dance, a subtle rhythm that unfolds over a lifetime. Every 18.6 years, the moon does not simply rise and set, it reaches its own celestial solstices. These are the lunar standstills, the extreme northern and southern limits of its rising and setting points along the horizon, while the sun's turning points repeat every single year. Capturing the moon's maximum wonder required a timescale that stretched across generations. Ancient astronomers engineered their stone monuments to act as long-term data loggers, with specific alignments targeting these far-flung lunar risings. A narrow gap between two massive stones might be perfectly framed to capture the glow of the full moon only once every 18 years, when it climbed to its most northerly peak. Another alignment, perhaps a low window in a burial chamber, would only be illuminated by the moon at its southern extreme. Identifying this cycle was an act of profound patience and coordinated observation. A grandfather would show his grandson the specific stone that marked the moon's furthest reach, and that grandson would teach his own grandchild where to watch, creating an unbroken chain of celestial memory. This was not just about marking a rare event, it was about understanding the moon's complete orbital personality, its long-term wobble known as precession. This knowledge had powerful practical applications. The major lunar standstill, when the moon rides highest and lowest in the sky, brings with it dramatic tidal extremes and unusual illumination patterns that affect animal behavior and navigation. To predict this was to anticipate nature's most potent rhythms. The successful tracking of this multi-generational cycle stands as perhaps the ultimate testament to ancient sky science, proving they saw the cosmos not as a series of random events, but as a grand, predictable machine whose deepest gears turned slowly, but could be understood with stone, fire, and unwavering human dedication. Stone and fire did more than mark time, they guided humanity across the trackless wilderness. For ancient mariners navigating the open sea or land travelers crossing unfamiliar deserts, these celestial markers were their only reliable maps. A single standing stone placed deliberately on a lonely headland could be aligned with the pole star, creating a permanent north marker visible day or night. Sailors would memorize these coastal sentinels, knowing that if they kept a specific stone in line with a certain star, they were on the correct course. On land, a series of cairns might be arranged to point toward a distant mountain pass, with the rising of a particular constellation confirming the traveler was headed the right way. This was a global positioning system carved into the very bones of the Earth. When darkness fell, fire beacons transformed the landscape into a network of celestial guidance. A chain of signal fires lit on high peaks could guide a ship safely into harbor or direct a caravan through a mountain range. The position of these fires was not arbitrary. They were placed to align with key stars. A navigator would watch for the beacon flame to appear directly beneath a bright star like Vega or Sirius, confirming they were on the true path. This required a deep, intimate knowledge of the sky, not as a static picture, but as a rotating sphere whose patterns shifted with the seasons. A star that guided a spring voyage would be absent from the autumn sky, so navigators had to know the entire annual dance by heart. They learned which stars heralded the coming of the calm sailing season and which constellations warned of seasonal storms. This celestial knowledge was the engine of exploration and trade. It enabled the Polynesians to settle the vast Pacific, using the stars as their highway. It allowed desert caravans to cross the Sahara by night, following the stars to distant oases. This was not abstract science, it was a practical tool for survival and connection, turning the entire cosmos into a guide for human movement. The stars became silent partners in every journey, their cold light enabling the warm exchanges of goods, ideas, and culture across continents. This cosmic knowledge demanded a permanent home, a sacred architecture that would lock the movements of the heavens into stone for all time. Around the world, from the deserts of Egypt to the jungles of Mesoamerica, ancient cultures raised temples and pyramids that were far more than places of worship. They were celestial machines. A pyramid's corner might be perfectly aligned with the North Star, anchoring the entire structure to the axis of the sky. A narrow temple doorway could be positioned so that on the dawn of the equinox, a single spear of sunlight would pierce the inner darkness and illuminate the statue of a god. These were not symbolic gestures, they were precise astronomical instruments built on a colossal scale. The very act of construction required a breathtaking understanding of geometry and celestial mechanics. To ensure that a passageway deep inside a mountain tomb would only be lit by the winter solstice sunset required years of planning and a society-wide commitment to a vision that would outlive every single person who laid its first stone. This was the ultimate fusion of faith and science. The stones themselves became the memory, preserving alignment so accurately that thousands of years later, we can still witness the same celestial events unfold within their walls. Fire played a crucial role in bringing these stone calendars to life. During a solstice or an equinox, great ceremonial fires would be lit within the temple precincts. The smoke would rise through precisely positioned openings, creating a pillar that seemed to connect the earth to the sky at the very moment the sun or moon reached its appointed place. This ritual transformed an abstract alignment into a powerful, multi-sensory experience for the entire community, solidifying the link between human ritual and cosmic order. The enduring nature of this cosmic architecture is our greatest window into the ancient mind. It proves that their understanding was not casual, but systematic, mathematical, and profound. They built their heavens on earth, creating a legacy in granite that continues to speak across the millennia. These celestial patterns were far too vital to be forgotten with a single generation. Without the safety net of written language, ancient astronomers developed a powerful and enduring system for preserving their knowledge, the living library of oral tradition. Around the communal fire, under a canopy of stars, the complex movements of the heavens were woven into epic stories, rhythmic songs, and sacred poems. A tale about a hero chasing 7 sisters across the sky was not mere fantasy. It was a memorable way to encode the annual rising of the Pleiades cluster and its connection to the planting season. The predictable 18-year rhythm of eclipses might be preserved in a legend about a celestial dragon that attempted to devour the sun and moon at regular intervals, only to be defeated by the gods each time. These narratives transformed abstract data into compelling drama, ensuring the information was not just remembered but cherished and eagerly passed down. The fire circle itself was the perfect classroom. Its flickering light created a focused, intimate space where elders could teach the next generation through ritualized recitation. The tone of voice, the specific cadence, and the accompanying gestures were all part of the mnemonic technology, designed to lock the information into memory with emotional and sensory anchors. To aid this process, they developed sophisticated memory techniques, often linking celestial events to permanent features of their own landscape. The story of the winter solstice sun might be physically tied to that specific notch between two distant hills where it always rose, making the landscape itself a permanent reference book. A song about the phases of the moon could be structured with 29 distinct verses, one for each night of the cycle. This fusion of story and place, of rhythm and ritual, created an unbroken chain of knowledge that could survive for centuries. The sheer accuracy of astronomical data preserved this way is a stunning testament to the power of the human mind. It proves that our ancestors were not just observers of the cosmos, but master archivists, building a legacy not in ink and parchment, but in the unforgettable language of myth and melody. Deep within the silent caverns, another kind of map was being drawn. On the rough canvas of cave walls and the smooth curves of pottery, ancient artists mixed charcoal and ochre with animal fat, creating a permanent record of the cosmos above. These were not simple doodles, they were meticulous observations. A sudden, brilliant new star appearing next to the crescent moon might be painted in stark white clay, capturing the awe of a supernova witnessed thousands of years ago. A series of dots trailing a fiery tail could be the earliest known depiction of a comet, its appearance carefully noted for future generations. This was astronomy rendered in art, a visual language that could communicate complex celestial events across centuries. The very pigments they used were born from their elemental toolkit, charcoal from fire and ochre from the earth, directly linking their artistic expression to their physical world. They encoded entire cycles into symbols. A circle with radiating lines might not just be a sun, but a symbol for the solstice. A series of crescent moons carved into a reindeer bone could chart the entire 29-day lunar cycle, a portable calendar carried by a shaman or a hunter. These symbols were a form of writing long before words existed to describe the planet's retrograde motion or the precise period between eclipses. When we analyze these artworks today, we are not just looking at primitive art, we are reading a scientific logbook. The placement of certain star clusters on a cave ceiling in Lascaux, for instance, matches the sky from 17,000 years ago, suggesting it was a deliberate star map. A pot shard from the American Southwest might show a perfect concentric circle eclipse event, with the sun's corona clearly depicted, proving they understood the geometry of such a phenomenon. This art served a dual purpose. It was both a practical record and a sacred text. By painting a comet on the wall, they were not only noting its passage, but perhaps also pleading with the spirits it represented. A depiction of the Pleiades rising was both an agricultural reminder and a mythological story frozen in time. In this way, art became the essential bridge, transforming cold observation into warm, living culture and ensuring that the secrets of the sky would never be forgotten. The stones of the medicine wheel held the entire cosmos in their circle. Across the Great Plains, Native American cultures constructed these sacred stone formations, which were far more than simple observatories. They were a profound synthesis of sky wisdom, spiritual belief, and the art of healing, all woven into a single, elegant design. A typical wheel featured a central cairn surrounded by an outer ring of stones, with lines of rocks radiating outward like spokes, often aligned with the rising and setting points of the sun at the solstices. But the alignments did not stop there. Certain spokes might point toward the heliacal rising of a bright star like Sirius, or the place where the crescent moon first appeared, marking important seasonal transitions. This celestial architecture was a permanent physical calendar, but its purpose ran infinitely deeper. The wheel embodied a holistic worldview where human health was inseparable from the rhythms of the earth and the orderly dance of the heavens. Each direction of the wheel held specific meanings, colors, and spiritual powers, connecting the individual to the greater cosmic balance. Illness was seen as a disruption of this balance, a person falling out of sync with the natural and celestial world. Healing, therefore, involved realigning the individual, and the medicine wheel provided the sacred map for this restoration. During powerful astronomical events, such as the summer solstice sunrise, the community would gather at the wheel. Fire ceremonies were essential, their flames and sacred smoke serving as a visible bridge between the earthly realm and the starry sky. As the sun's first rays shot precisely down the solstice alignment spoke, bathing the central cairn in light, prayers for health and harmony would rise with the smoke. This ritual powerfully demonstrated that cosmic order was not an abstract concept, but the very foundation of community well-being. The medicine wheel represents one of humanity's most sophisticated intellectual achievements, a place where the practical science of predicting seasons was seamlessly fused with the spiritual art of healing. It proves that for our ancestors, to understand the stars was to understand life itself. The Babylonians transformed the ancient art of sky watching into a rigorous mathematical science. Their great innovation was the clay tablet, a permanent record that could store celestial data for centuries. Yet their methods were deeply rooted in the old ways, building directly upon the foundational skills of observation, first perfected with stone sightlines and fire-lit platforms. In their towering ziggurats, which functioned as immense, man-made mountains for observing the heavens, the ritual use of sacred fire continued unabated. The flames that illuminated their nighttime ceremonies were the direct descendants of the bonfires that once guided ancient watchers on lonely hillsides. This fire was not just for light, it was a spiritual conduit, maintaining the vital link between the human realm and the divine cosmos they were so meticulously measuring. Their greatest achievement was the Venus tablet, a meticulous log of the planet's complex dance over 21 years. They did not merely note its appearance, they calculated its cycles, discovering that 8 solar years almost perfectly equal 5 of Venus's synodic periods. This allowed them to predict its future movements with a precision never before seen. This was the monumental leap from simply watching the sky to forecasting its behavior, from recording what happened to modeling what would happen next. To achieve this, they developed an entire new language for the sky. They divided the sun's path into 12 equal sections, creating the zodiac, a celestial highway that gave every star and planet a precise address. They refined the system of celestial coordinates, allowing them to pinpoint a star's location with mathematical clarity, rather than just its position relative to a mountain peak. The Babylonians proved that the deepest cosmic truths are not found by abandoning the old tools, but by building upon them, transforming the primal language of stone and fire into the enduring script of mathematics. Imperial astronomers of ancient China gazed at the same stars, but they saw a celestial bureaucracy mirrored from their earthly empire. They transformed the sky into a grand, orderly kingdom, charting its every official and its every unexpected event with bureaucratic precision. Their primary tools remained elemental stone sighting tubes for precise positioning and the steady burning of incense sticks or calibrated oil lamps to mark the passage of time through the night. This marriage of simple technology and systematic record-keeping produced the world's first comprehensive star catalogues, meticulously logging the positions of hundreds of stars. But their vigilance went far beyond mere mapping. They were the universe's ultimate scribes, noting every anomaly. A guest star, what we now call a nova, would suddenly appear where none had been before, and its position, brightness, and duration were carefully inscribed onto bamboo slips and later silk scrolls. A broom star, a comet with its sweeping tail, was not just an omen but a celestial event to be quantified, its path across the constellations tracked and preserved for future generations. This relentless documentation was not driven by pure curiosity. It was a state-sponsored duty. The emperor's mandate of heaven was believed to be reflected in the heavens, so a stable, predictable cosmos affirmed his righteous rule. Astronomy was the ultimate tool for statecraft and survival. Their calendar was a masterful lunisolar creation, harmonizing the moon's phases with the sun's year. To keep this complex system in sync with the seasons, essential for taxing agriculture and planting crops, they periodically inserted an intercalary month. This required an intimate, ongoing conversation with the sky itself. The endurance of this tradition is its most stunning feature. For over 2,000 years, through the rise and fall of countless dynasties, the Astronomical Office never ceased its watch. This unbroken chain of data, a celestial diary stretching across millennia, is a gift to modern science. Astronomers today use these ancient records of nova to study stellar evolution and the observations of comets to refine the orbital paths of these icy visitors. The Chinese achievement stands as a monumental testament to what a culture can accomplish when it watches the sky not just for a lifetime, but for 1,000 generations. Deep in the Mesoamerican jungles, a civilization achieved a cosmic precision that still defies easy explanation. The Maya did not merely watch the stars, they engineered their entire world to measure them, building cities that doubled as celestial calendars. Their temples were not just pyramids reaching for the heavens, they were precisely angled instruments. A corridor between two structures might align perfectly with the rising point of Venus on a specific day in its complex cycle, while a window in a palace wall would frame the sun only on the day it passed directly overhead at the zenith. This architectural astronomy was a language written in stone and light. The foundation of this system was a mathematics far more advanced than anything found in Europe at the time. They conceived of the zero, a revolutionary idea that allowed for complex place-value notation and calculations spanning vast stretches of time. With this numerical power, they computed the length of the solar year to a degree of accuracy that would not be matched in the old world for centuries. They tracked the synodic period of Venus, the time it takes for the planet to return to the same position relative to the Sun, with an error of just 1 day in 500 years. This was not guesswork, it was the result of generations of priest astronomers meticulously recording data on bark paper codices, watching the same celestial events unfold again and again from their stone observatories. This astronomical knowledge was the very engine of their society. The appearance of Venus as the morning star was not just a beautiful sight, it was a potent omen that could dictate the timing of warfare. A solar eclipse was a moment of cosmic danger, demanding specific rituals by the king to maintain the world's balance. The agricultural cycle was guided by the stars, ensuring corn was planted at the optimal moment. Their famous long count calendar was the ultimate expression of this temporal mastery, a linear count of days from a mythical starting point that allowed them to plot history and prophecy on a scale of millennia. It was a system designed to make sense of vast cosmic time, proving that their intellectual vision extended far beyond the lifespan of any single ruler or dynasty. The Mayan achievement stands as a powerful testament to what the human mind can accomplish with nothing but determined observation, intellectual courage, and an unshakable belief that the cosmos operates by knowable rules. A civilization that lived by the rhythm of the Nile turned the vault of the night into a precise, star-driven clock. The ancient Egyptians engineered a system of timekeeping so elegant it was painted on the inside of coffin lids and carved into the ceilings of tombs for the dead to carry into the afterlife. This was the Deccan system, a celestial map built not on constellations as we know them, but on 36 small groups of stars called decans. Each decan would rise above the eastern horizon just before the sun, an event known as its heliacal rising, and then dominate the night sky for a period of 10 days before the next decan took its place. Over the course of a year, this created a perfect sequential parade of 36 star groups, each one marking a new 10-day week in the Egyptian calendar. Imagine a star rising at dawn on the first day of the flood season, and you would know exactly where you were in the annual cycle of the river that gave life to your entire world. To use this star clock, an astronomer needed only the simplest of tools, their own body and a clear eastern horizon. They would use a sighting tool, perhaps a notched stick or a string with a plumb bob, to ensure a consistent viewing angle. Then they would watch for the moment a specific decan became visible in the pre-dawn glow, its light finally strong enough to pierce the twilight. This single observation told them both the time of night and the week of the year. Inside the tombs, these star clocks were depicted with exquisite detail. A seated figure representing the astronomer is shown with a series of decans marching across the sky above him, each one labeled and positioned to show its correct place in the nightly rotation. This was a functional manual for eternity, ensuring the departed could also navigate time. The entire system was synchronized by one celestial event of profound importance, the heliacal rising of Sirius, the brightest star in the sky. Each year, just before the Nile's life-giving floods began, Sirius would reappear in the dawn sky after a 70-day absence. This was the Egyptian New Year, a moment of both practical urgency and deep religious significance. It signaled that the waters were coming, that the fields would soon be fertile, and that the cycle of life was beginning anew. Their calendar, based squarely on this Sirius cycle, was 365 days long, one of the first solar calendars in human history. They understood that the starry clock and the sun's journey were two parts of a single, grand mechanism. This cosmic knowledge was the bedrock of their society. It told farmers exactly when to prepare the fields and when to harvest. It told priests the precise moment to begin the great festivals honoring the gods who controlled the universe. The decan system was more than just timekeeping. It was the very heartbeat of a civilization, a rhythm written in the stars and perfectly understood by the people who watched them from the banks of the Nile. The world's greatest ocean was not a barrier but a highway. For the Polynesian wayfinders, the vast emptiness of the Pacific was a familiar neighborhood, its paths illuminated by a map of stars. They set sail across thousands of miles of open water in double-hulled canoes, carrying no compasses, no charts, and no clocks. Their only instruments were their deep knowledge of the sky, the waves, and the wind. These navigators were living observatories, their minds containing a celestial compass of breathtaking complexity. They knew not just the names of stars, but their precise rising and setting points on the horizon. Each star was a fixed beacon, and as one star set, another would rise in a predictable sequence, creating a celestial pathway across the ocean. A journey from Tahiti to Hawaii meant following the star path of Hercule, steering the canoe so that this specific guide star remained at a constant bearing overhead. But the star compass was far more than a single point of light. It was a mental construct dividing the horizon into 32 equal houses, each one named for the star that rose or set there. The navigator, standing alone on the deck through the night, would feel the canoe's position by watching which star houses were active around them. This required a constant, dynamic recalibration of their mental map as they sailed, a real-time celestial calculation performed entirely in the mind. Their knowledge extended deep into the subtle rhythms of the sea itself. They read the ocean swells like roads, recognizing how they reflected off distant islands still far beyond the horizon. They watched the flight patterns of birds and the types of cloud formations that gathered over land. The wayfinder was a unified sensor, processing information from the sky, the sea, and the air to maintain a dead reckoning of their position for weeks on end. This was not a system of written formulas, but an oral tradition passed from master to apprentice through years of rigorous training. The survival of entire voyaging communities depended on this sacred knowledge. The Polynesian expansion across the Pacific, one of the most incredible feats of exploration in human history, was accomplished by sailors who truly understood that the heavens were not above them, but all around them, a guiding sphere they learned to sail within. A quiet revolution has been unfolding in the way we see our ancestors. This is the field of archaeoastronomy, where laser theodolites and satellite imaging now scrutinize the same stones once aligned by firelight. It is a discipline built on a simple, powerful premise: to listen to the ancient sites themselves. By applying this rigorous scientific lens, researchers have moved beyond speculation and uncovered a hidden language of celestial geometry etched into the landscape. They are not just studying ruins, they are decoding a sophisticated science that was written in granite and sunlight. This interdisciplinary approach weaves together threads from astronomy, archaeology, and anthropology, creating a far richer tapestry of understanding than any single field could achieve alone. A striking pattern that has emerged from this global investigation is the principle of independent discovery. Cultures separated by vast oceans with no possible contact all arrived at the same profound realizations. The people of ancient Britain built Stonehenge to mark the solstices, while on the Yucatan Peninsula, the Maya engineered windows in their temples to capture the zenith sun. Both understood the solar year with stunning accuracy, yet they developed their knowledge in complete isolation. This recurring theme suggests something fundamental about humanity itself, an innate drive to comprehend the cosmos and find our place within its cycles. The work of archaeoastronomers often feels like a form of resurrection. They use computer models to recreate the night sky as it appeared thousands of years ago, proving that a specific alignment in a Scottish burial cairn was designed to capture the light of a midwinter moon. They analyze the wear patterns on a carved stone in the American Southwest and realize it served as a precise gnomon for tracking the seasons. Each of these discoveries is a validation, a moment where modern science confirms the intellectual achievements of the ancient mind. It proves that their celestial maps were not lucky guesses, but the result of patient, generational observation. This revolution in thought forces us to abandon outdated notions of primitive cultures. We now see them for what they were: brilliant astronomers who used the world around them as their laboratory, achieving a cosmic precision that commands our respect and continues to reveal its secrets to those who know how to look. Silent stone circles still guard their secrets across the globe. From the windswept Salisbury Plain in Britain to the parched sands of Egypt's Nabta Playa and the ancient soils of China's Taosi, these rings of granite and limestone speak a universal language of celestial wonder. They were built by cultures separated by oceans and millennia, with no shared blueprints, yet they all point toward the same cosmic events. The summer solstice sunrise at Stonehenge finds its echo in the alignment of the Nabta Playa stones with the same pivotal moment. The Tausi Observatory, with its precise earthen ramparts, carefully tracked the sun's journey just as the Great British Circle did. This is not a case of shared instruction, but of independent discovery. Humanity, when faced with the same sky, arrived at the same brilliant conclusions time and again. The fundamental impulse to mark the sun's turning points, to measure the moon's wanderings, and to seek order in the heavens seems to be woven into our very DNA. These circles were more than just temples, they were the world's first open-air laboratories. Within their sacred boundaries, generations of watchers collected data, tested theories, and refined their understanding of cosmic law. They used the stones as fixed sightlines, turning the entire horizon into a calibrated instrument for measuring the movements of the sun, moon, and stars. Modern archaeologists, armed with laser scanners and 3D modeling software, are only now beginning to appreciate the full scope of their astronomical functions. What we once saw as simple solstice markers are now understood to be complex predictive machines. Some alignments appear to track the slow, 18.6-year cycle of the Lunar Standstills, while others may have been used to anticipate the rare and fearsome solar eclipse. The very presence of these circles on nearly every continent tells a profound story. It is the story of a species that first looked up at the starry void and refused to be intimidated. Instead, we reached for stones and began to build a conversation with the cosmos, a dialogue carved in earth and stone that continues to resonate today. Fire transformed the abstract patterns of the sky into a living, breathing part of human culture. Across the world, from the high plains of the Americas to the stone circles of Europe, communities gathered for fire ceremonies precisely timed to celestial events. These were not separate from the science of astronomy, they were its ultimate expression. When a priest lit a great bonfire on the night of the winter solstice, it was a communal confirmation that the sun had reached its lowest point and was now returning. The ritual was the test, and the celestial event was the result, proving the prediction correct for all to see. This created a powerful feedback loop, where the successful timing of the ceremony reinforced the accuracy of their astronomical knowledge and the authority of their calendar. The fire itself was a dramatic reenactment of the cosmos, its flames mirroring the sun and its sparks echoing the distant stars. On a night when the moon turned a deep, coppery red during an eclipse, the fire ceremony below became a terrestrial companion to the celestial drama, its smoke rising as if to meet the shadowed moon. For a planetary conjunction where two bright wanderers drew close in the sky, the fire served as a third point of light, connecting the event to the human world. These moments of communal witnessing were the primary method of knowledge transmission. An elder would point to the sky, naming the constellations and planets, while the younger generation watched, the story forever linked in their memory to the heat of the flames and the scent of the smoke. This is how complex astronomical cycles were memorized and passed down for centuries, not as dry data, but as powerful, multi-sensory experiences. The fire ceremony was the glue that bound practical observation to spiritual belief, proving that to understand the heavens was to participate in their eternal rhythm. This wisdom was far too valuable to be trusted to chance or a single lifetime. Its survival across centuries demanded a deliberate and sophisticated system of transmission, a sacred relay race of knowledge passed from master to apprentice. The education of an astronomer priest was a lifelong commitment, beginning in childhood with the simple task of memorizing star patterns and seasonal stories told by the elders around the evening fire. This was not casual storytelling, it was a rigorous oral curriculum. Complex planetary cycles were encoded into epic poems, their rhythmic verses serving as a mnemonic device to lock in the timing of a retrograde loop or the rhythm of an eclipse cycle. The student learned to associate each celestial event with a specific landmark, turning the entire surrounding landscape into a three-dimensional textbook. That distant mountain peak was not just a rock, it was the winter solstice sunrise marker, its meaning reinforced year after year. This knowledge was often a closely guarded secret, preserved within specific families or elite social groups. A father would teach his son the precise alignment for the lunar standstill, and that son would in turn teach his own child, creating an unbroken astronomical lineage that could span dozens of generations. This ensured the methods remained pure and the observations consistent decade after decade. But memory alone was not always enough. They built redundancy into their system, encoding the same data in multiple forms. The same solstice alignment was captured in the architecture of a temple, painted on a ceremonial pot, and sung about in a seasonal hymn. If the oral tradition was disrupted by war or famine, the stones themselves would still speak, silently marking the sun's turning point for any future generation who learned to read their language. This multi-layered approach to knowledge preservation, oral, architectural, and artistic, proved incredibly resilient. It allowed celestial science to survive the collapse of empires, long migrations, and profound cultural shifts. The fundamental importance of this cosmic calendar to agriculture, religion, and social order meant that someone, somewhere, always had a vested interest in keeping the sky wisdom alive. The very continuity of human civilization is mirrored in this unbroken thread of celestial understanding, a testament to our species' deep-seated need to comprehend the clockwork of the cosmos. Behind the apparent simplicity of stone and fire lay a hidden architecture of numbers and angles. The ancient astronomers were not just observers, they were geometers, using the principles of shape and measurement to quantify the cosmos. They developed practical geometry to calculate the heights of pyramids, the distances to the horizon, and the precise angles of celestial bodies above them. This was not the abstract geometry of a classroom, but a hands-on science born from necessity. By driving two stakes into the ground and sighting along their tops toward a star, they created a simple but effective instrument for measuring angular separation. The distance between the stakes and the length of the sighting rod gave them all the information needed to calculate an angle using basic triangular relationships. This allowed them to map the sky not just as a story but as a diagram. Their number systems, though unfamiliar to us, were perfectly engineered for these tasks. The Babylonians used a base 60 system, a choice whose legacy endures in our 60-minute hours and 360-degree circles. This system was brilliant for astronomy because 60 is divisible by so many numbers, making complex fractions easy to handle when dividing the circle of the sky. The Maya, with their advanced concept of zero and place value, could perform calculations spanning millions of days to track planetary cycles. These were not primitive counting methods, they were sophisticated tools that enabled prediction. The very concept of periodicity, the idea that celestial events repeat in predictable cycles, is a mathematical one. It emerged directly from generations of recorded observations. They noticed that 5 Venus cycles nearly equaled 8 years, or that 235 lunar months almost perfectly matched 19 solar years, a period known as the Metonic cycle. To discover these patterns, they had to think in terms of ratios and proportions, comparing one cycle against another to find a common denominator in the grand symphony of the sky. This mathematical foundation transformed their understanding from a record of what happened to a model of what would happen next. They could now predict not just the rough season of an eclipse, but its precise timing and path. The emergence of mathematics from the silent, patient observation of the stars reveals a profound truth. that our drive to measure the world and our desire to understand the heavens are one and the same impulse, two sides of the same stone tablet. The sky was not a distant mystery but the ultimate source of order. Ancient cultures saw the perfect regularity of the sun and stars as proof of a universal law, a cosmic blueprint that human society was meant to mirror. This celestial order became the foundation for their entire worldview, their politics, and their understanding of right and wrong. In Egypt, the concept of Mat represented this divine balance, a principle of truth and harmony that was reflected in the predictable rising of Sirius and the unwavering path of the sun. A pharaoh's primary duty was to uphold Mat on earth, ensuring that human laws aligned with the unshakable laws of the cosmos. When the seasons turned as predicted and the Nile flooded on schedule, it was evidence that the kingdom was in tune with the universe. This same idea resonated in Mesopotamia, where the gods had established the fundamental decrees of civilization, which were written in the movements of the planets. To live a moral life was to live in accordance with this observed celestial harmony. The entire social structure, from the king down to the farmer, found its justification in the sky. The ruler was often seen as a direct descendant of the sun or stars. His authority derived from his ability to interpret and maintain this cosmic order. When he performed a ritual at the solstice, he was not just honoring a god, he was actively participating in the machinery of the universe, ensuring its continued function for the benefit of all. This profound connection meant that astronomy was never a separate science. It was the very fabric of philosophy, governance, and ethics, woven together into a single, coherent understanding of reality. This cosmic framework then dictated the physical shape of their world, from the grandest temple to the layout of a humble village. The central avenue of a city might be aligned with the axis of the sun's path, making the main street a terrestrial echo of the celestial highway. A temple's inner sanctum could be positioned to receive the first light of the equinox, transforming the building from a mere place of worship into an active participant in the solar cycle. Even domestic architecture followed this logic. The orientation of a house, the placement of its windows to catch the morning sun, these were not arbitrary choices. They were daily reminders that human life was embedded within a larger, orderly cosmos. This celestial influence extended to the most practical aspects of survival. The agricultural calendar was a sacred text written in the stars. The appearance of the Pleiades told the farmers in one region to sow their seeds, while the heliacal rising of Orion warned another culture of the coming winter storms. This was not just folk wisdom. It was a systematic application of astronomical data to ensure the community's prosperity. The development of writing itself was often driven by the need to record these complex celestial cycles. The earliest glyphs in many cultures are numbers and calendar dates, etched into bone or clay to track the passing of moons and the return of seasons. Writing began in a very real sense as a technology for preserving time, a direct result of humanity's need to document the orderly dance of the heavens. This cultural cosmology reveals the ancient mind as fundamentally interconnected, where every stone placed, every law passed, and every seed planted was a conscious reflection of the cosmic order witnessed overhead. The silent observations of the ancients are now a critical dataset for modern astrophysics. Those meticulous records of supernova and comets, carved into bone and painted on cave walls, provide a unique window into the long-term behavior of our universe. When astronomers today study the gradual slowing of Earth's rotation or the changing orbits of comets, they rely on these ancient eyewitness accounts to extend their timelines back for millennia. A Babylonian record of a lunar eclipse from a specific date allows scientists to calculate the precise moment it occurred, revealing tiny variations in our planet's spin over centuries. This is not just historical curiosity, it is active, cutting-edge science built upon a foundation of stone and fire. The very methods used to decode these ancient sites have revolutionized archaeology itself. The precise celestial alignments of stone circles provide a powerful tool for dating archaeological layers. If we know a tomb doorway was aligned with the star Sirius in a specific year, we can calculate the exact date of its construction based on the slow precession of Earth's axis. This technique, known as Archaeoastronomy, turns the heavens into a calibration tool for human history. Our modern conception of time is a direct inheritance from these early watchers. The length of our year, the division of the day into hours, and the very structure of our calendar were all refined over generations by astronomers tracking shadows and star risings. Even in the vast, airless void of space, the old ways persist. The principle of celestial navigation, reading your position from the stars, is nearly identical to the methods used by Polynesian wayfinders. While our spacecraft use computers for calculation, the underlying mathematics of plotting a course by the fixed stars is a timeless art. This unbroken thread of knowledge connects the engineer at mission control with the ancient mariner steering by the Pleiades, both using the same cosmic map to find their way. The greatest legacy is not any single discovery, but the enduring power of the scientific method itself, a tradition of patient observation and systematic thinking that began when the first human used a standing stone to measure a shadow. Yet for all we have rediscovered, profound mysteries still linger in the stones. The sheer precision of certain alignments defies easy explanation. Consider the Great Pyramid of Giza, positioned with a near-perfect orientation to the cardinal directions, a feat of accuracy that would challenge modern surveyors. How was this achieved on such a colossal scale with only rudimentary tools? The mathematical constants seemingly encoded in its dimensions suggest a sophistication we are still struggling to comprehend. This precision is not an isolated case. At sites like Stonehenge, the arrangement of stones predicts not only solar and lunar extremes, but also more complex events like eclipses, all calculated with a degree of certainty that seems to stretch the limits of what we believe was possible with their technology. This forces a difficult question: did these cultures possess advanced techniques that were simply lost to time? Knowledge that vanished when the last oral historian died. Another enduring puzzle lies in the global echoes. Why do cultures separated by oceans and continents share such similar astronomical concepts, from solstice markers to zenith tubes? Was this purely the result of independent discovery, the human mind naturally arriving at the same conclusions when faced with the same sky? Or does it hint at forgotten voyages, at threads of contact and exchange that our current historical models have yet to capture? The records they left behind add another layer of mystery. Some ancient star charts depict the night sky with configurations that do not match our own, potentially revealing a slow precession of the stars over millennia. Other texts describe celestial events like sudden bright new stars or strange comets that we cannot find in our modern catalogues, leaving us to wonder what they actually witnessed. Perhaps the greatest enigma of all is the human one, the mechanism of memory itself. How was such complex, quantitative knowledge transmitted across hundreds of generations without a single written formula? The oral tradition was clearly a powerful engine, but the sheer volume of data, the precise timing of planetary cycles and eclipse patterns, suggests a mnemonic technology far more robust than we can currently conceive. These are not just academic curiosities, they are open invitations. Every unsolved alignment, every anomalous record, is a whisper from the past, a challenge to our assumptions and a reminder that the full story of how our ancestors mapped the heavens is still being written. A modern astronomer once spent a full year tracking the sun using only a single wooden post. This was not a hobby, but a rigorous experiment in recreating the past. Across the globe, researchers in the field of experimental archaeology are turning away from their high-tech telescopes and computers, choosing instead to rely solely on the tools our ancestors had: stone markers, firelight, and their own patient eyes. Their goal is simple yet profound: to test whether the celestial precision we marvel at in ancient sites could truly have been achieved with such elemental technology. The results have been startling. Volunteers with no prior astronomical training, guided only by oral instructions and simple stone alignments, have successfully predicted the exact day of the solstice. Others have used carefully shielded bonfires to illuminate stone sightlines, allowing them to track the slow retrograde loop of Mars against the fixed stars with an accuracy that rivals early telescopic observations. These experiments have proven it is entirely possible to record the complex Saros cycle of eclipses using nothing more than a series of notches on a long bone or a sequence of marked stones. The true challenge these modern pioneers discovered was not the lack of technology, but the mastery of environment. They learned that the clarity of the air is everything. A still, cold night after a rain provides a perfect window to the stars, while summer haze can render the most careful alignment useless. The selection of the observation site became a critical science in itself. A high ridge with a clean horizon view was worth more than 1,000 calculations. Most importantly, they developed strict observational protocols: the exact posture for sighting, the specific way to shield the eyes from stray firelight, and the disciplined routine of recording data immediately. These recreations have transformed our perspective from one of skepticism to one of deep respect. What once seemed like magical feats are now understood as the products of refined skill, generational patience, and a profound partnership with the natural world. The stones did not work alone. They were the faithful instruments of a keen and dedicated human intelligence. This journey through the world of ancient astronomy is ultimately a story about us. It reveals a human ingenuity born not from complex machinery, but from profound patience and a deep, abiding connection to the cosmos. With nothing more than stone and fire, these early scientists mapped the intricate dance of planets, predicted cosmic events with stunning accuracy, and built a legacy of knowledge that continues to impress modern researchers. Their achievements stand as a powerful reminder that true understanding does not always require technological sophistication. The essential ingredients are careful observation, systematic thinking, and the simple courage to ask big questions of the universe. The methods they painstakingly developed, from tracking shadows to encoding data in myth, laid the entire foundation for all subsequent astronomy and much of modern science itself. When we look up at the same stars they observed millennia ago, we are not separate from their quest. We participate in the oldest human tradition of all, a shared legacy of cosmic wonder. Their story challenges us to see the universe with fresh eyes, to appreciate both the vast distance we have traveled and the timeless connection we share, forever bound by our eternal relationship with the night sky.